Hello, everyone. This is Jim May, Marketing Manager at Index Corporation. Thank you for joining us today. I'm going to turn things over to our main speakers in just a second, but a couple announcements to get us started. First, we realize some people are still working and joining us from home. If you are joining us from home today, and if you are on a VPN network, you may want to log off and log back on off of the VPN. During the presentation, we're going to share some video, and we have received feedback that VPN may interfere with the playback of that. Also, you should see a box where you can enter questions. We will hold those till the end, but any questions that occur to you at any point during the presentation, just enter those, and when we get to the end of the webinar, we will go through those one by one and make sure they all get answered. So without any further ado, I am going to turn things over to Ross Kenyon and Tim Partridge.
Thanks, Jim. Hello, everyone. Welcome to our webinar about multi-spindle technology and your reshoring strategy. My name is Ross Kenyon. I'm the Applications Engineering Manager here at Index Corporation. I've been with Index for 20 years, 2 years in Germany and 18 years here in the States. During that time, I've worked mainly in the technical sales department and applications department, focusing on the multi-spindle machines. Now I'm going to hand over to my co-presenter, Tim Partridge, to tell you a little bit about himself.
Good afternoon, everybody. Thanks for being here. My name is Tim Partridge, and I'm the Regional Sales Manager for the East Coast for the Index Corporation. And as the slide says, I've been at Index for 13 years, 44 years in the industry in various parts making, engineering, and sales roles. And with that, I'll hand it back to Ross to start our webinar.
Thanks, Tim. So last year, Kenyon's U.S. manufacturing import ratio fell for the first time since 2011. This indicates that offshoring is receding. This resulted in the largest swing in their reshoring index in 5 years, and this was driven by a 17% decrease in imports from China. Increasing trade tariffs are also making reshoring more attractive. Due to the recent COVID-19 pandemic, we've seen that we need to be nimble and responsive to our customers' needs and be able to do more with less. We can also see that from Thomas's monthly survey of over 1,000 US manufacturers that increasingly concrete plans to reshore are happening. You can see below in the graph that from February through to April, the number of companies likely to reshore has risen to 66%, and of those, 20% say that reshoring is likely. So the challenges of reshoring work are how you keep prices low but still work profitable, how you do more when the skilled labor shortage is growing, which I'm sure you all are familiar with, how do you increase your capacity, staying within the footprint of your existing facility, and how do you increase your agility to quickly respond to ever-changing customer needs, and how do you position yourself for long-term success. There's a traditional trade-off between doing work quickly and high quality, incurring high costs. So how do we avoid that? Well, the multi-spindle gives you a new perspective. So you can do work quickly with high quality at low cost. We have customers producing parts on a multi-spindle right now, which are of a higher quality than what they are producing on Swiss-type lathes or twin-spindle machines in the past. Primary constraints to growth are floor space, skilled labor, and having the production capacity. Multi-spindles address all three of these constraints. Today's multi-spindle machine is a completely different animal than the cam-driven parts of different machines of yesteryear. Machines these days have minimal setup and changeover times due to rapid change tooling interfaces such as CAPTO, VDI, WFB, the ability to use standard tooling with inserts. There's no need to use special form tools anymore. Multi-spindle machines are now economical for lot sizes as small as 5,000 pieces. Multi-spindles are extremely flexible in processing. Now you have independent spindles with C-Axes, CNC slides, live tooling capability, Y-axis. We have enough tool capacity now to be able to make complex parts complete, including backworking. There are lots of parts out there which are currently made on Swiss-type machines or twin-spindle lathes that can be efficiently produced quickly on multi-spindle machines. Typically, these are parts which can fit in your hand, so bar parts less than 2 inches, have a length to diameter ratio of less than 3.5 to 1, are lot sizes of 5,000 or more, require live tool work such as cross drilling, milling, thread milling, polygon turning, etc., and parts need to be complete in a single operation. Benefits of multi-spindles are that they provide the capacity of 6 to 8 traditional multitasking turner centers in the footprint of one. You have incredibly fast cycle time. You increase your operator output by a factor of 5 or more. You can redefine the square footage of your facility and dramatically reduce your cost per piece. The multi-spindle offers increased rigidity and vibration resistance when compared to smaller Swiss type or twin spindle machines. You can improve your traceability and visibility within your plant. Multi-spindles enable you to have a competitive advantage and compete for new work and differentiate yourself from competitors. So as I mentioned, multi-spindles offer cycle time reductions, which can be as much as 87%. Cycle time reductions occur because you're machining in parallel, so you have operations going on at the same time. So you're getting some operations for free. Your longest cycle is your bottleneck, which determines your cycle time. Other stations can therefore be slowed down to optimize surface finish, part quality, and tool life. In spindle positions, we can have multiple tools, so with a big tool capacity enabling you to make complex parts. Multi-spindles require no more operator hours than a single spindle machine. This allows your worker to produce as much as 6 times product and generate the corresponding savings in labor. Multi-spindles offer drastic reduction in square footage. So when you have 6 to 8 single spindle machines in a smaller space, the multi-spindle takes up maybe 20% of the capacity that the Swiss type machines will. So you can see in the image below that the multi-spindle on the left and 6 Swiss type machines, the multi-spindle is 20% of the floor space. So less floor space enables you to have better overall control and visibility of the processes going on in your shop. As productivity is one of the largest determinants of part cost, multi-spindles routinely achieve the lowest possible cost per piece. The lower cost per piece offsets the initial higher investment. Parts are made on one machine by one operator, consuming less energy and resources. Due to the construction and weight of multi-spindles, they offer excellent vibration, dampening, and rigidity for increased part quality and process stability. Multi-spindles are designed to avoid the transfer of vibration from one spindle to another or one tool to another, and are highly stable compared to traditional machines. As I mentioned before, non-determining cycle time positions can be slowed down to further enhance surface finish, part quality, and tool life. The vibration is also kept to a minimum by having Z-axis quills which run in hydrostatic bushings that keep the Z-axis free of friction, wear, maintenance, and backlash. By using one machine to produce a quantity of work that would otherwise take 5 or 6, part tracking and 100% traceability is much easier to achieve. The use of multi-spindles allows far more efficient use of your resources. You're using one operator, less power compared to multiple single spindle machines, and you have lower preventive maintenance and spare parts requirements from one machine versus multiple single spindle machines. You can see in the example below, one multi-spindle uses about a third of the power of 6 Swiss type machines. Now I'm going to take you through a real-world example. The component on the right is a titanium medical component. It's just less than 600 thousandths in diameter and 600 thousandths in length. The part requires turning, milling, drilling, and thread milling. The part has very tight tolerances, some less than 5 thousandths total, and the part was machined complete on the multi-spindle, including deburring. The initial investment for the part was $2 million for a multi-spindle versus $350,000 for a Swiss type machine. You can see that the finance period is the same at 84 months. The interest rate is 5.75% for both, which results in a monthly payment of just over $5,000 for the Swiss type machine and just under $29,000 for the multi-spindle. Where the multi-spindle shines is the cycle time. The cycle time for the multi-spindle is 62 seconds versus 348 for the Swiss type machine. If we take a shop which runs 24 hours a day, 5 days a week at 83% efficiency, that means 20 hours per day we are producing parts. So therefore, in a week, you just get over 1,000 on the Swiss type machine and 5,800 on the multi-spindle. In a year, that means 51,724 parts on the Swiss type machine versus 290,323 on the multi. The cost per piece is similar, $1.18 on the Swiss type machine versus $1.20 on the multi. If we look at the labor rate, we have the same labor cost for the multi and the Swiss type machine, but we're producing significantly more on the multi-spindle machine, so 5,806 versus 1,034 on the Swiss type machine. This results in a labor cost per piece on the Swiss type machine of $3.48 versus 62 cents on the multi-spindle. If we add it all up together, then the total cost per piece on the Swiss type machine is $4.66 versus $1.82 on the multi-spindle. So a summary, the multi-spindle provides an annual capacity of 290,323 parts at $1.82 per piece, while the single spindle only produces 51,724 parts at $4.66 a piece. In other words, the multi-spindle offers 561% of the capacity with a 61% reduction in cost per piece and a 66% reduction in power consumed. We really are doing more with less. So to recap the benefits of a multi-spindle. So CNC multis provide the capacity of 6 to 8 traditional multitasking centers in the footprint of one, offer incredibly fast cycle times by overlapping processes, boost your operator's output by 5 or more. You can redefine the capacity to square footage of your facility, enabling you to take on more work. You can dramatically reduce the cost per piece. You have a machine with increased rigidity and vibration resistance, producing more parts of better quality and process stability. You can improve the traceability and visibility within your shop. So you differentiate yourself from competitors as well, so you won't have to keep competing for the same work. So now I'm going to hand over the presentation to Tim Partridge, and he's going to tell you a little bit about the Index MS series. Thank you.
Hey, thanks, Ross. And again, thanks for everybody being here today, spending some time with us. What I like to do in the portion of this webinar is go through the MS product line and some of its features that could possibly help you, participate in the upcoming reshoring efforts. So flexibility and capability are the name of the game with the Index multi-spindle. Flexibility, highly configurable, meaning that the Index multi-spindle is has available all the CNC turning features that and milling features, and additionally all the conventional screw machine features as well. So both of these are equal to the total package. The free chip fall and superior access via open work area. This is a huge focus of the Index multi-spindle, the openness of the work area. We don't have the center slide in there that catches chips and gets in your way when you're trying to turn the wrench. And all this actually leads to rapid changeover of parts. If you're actually thinking about a multi-spindle, do yourself a favor, make an appointment with your salesman. Take a look at a Index multi-spindle, maybe at a customer's or at the Index showroom. Just take a look inside the window and journey through the machine a bit, and then go see the competition, and you'll see exactly what I'm talking about. Not to mention the accuracy, thermally stable design, and the connected, meaning that we are IX 4.0 ready for all your data collection needs. So the heart of this multi-spindle is the spindle drum that we're looking at right now. And the spindle drum is made up of 6 or 8 fluid-cooled motorized spindles in the drum, hollow shaft motors, and their variable speeds from 0 to 10,000 RPMs throughout the product line. And a simple thing, but a really big focus is that each one of these spindles is independent and can be programmed and cut while machining. C-Achse is available at every spindle for all your positional machining needs. And of course, last but not least, our impeccable repeatability with our hearth coupling, 3-part hearth coupling. And the tool slide concept is probably, is one of the biggest focuses of this machine as well too. Our unique tool slide concept is the key to the flexibility of the index system. Up to 12 to 16 tool slides, X, Z, or Y axis. Be known that Y axis is available up to 4 of these slide positions within the product line. Up to 14 tools for backworking, which is a very flexible concept, as we are very capable for intense backworking parts. Multiple tools per slide, so we can stack up a couple of tools and utilize the X-axis that we have, and C-axis at every spindle position as well too. The Z-axis of the slide is encompassed in the hydrostatic bearing design, the C-axis, which eliminates wear, and the direct drive X-axis motor. You can see by this picture here that the motor that's off the end of these slides is our X-axis motor, and this is a bit of a not a new thing, but came out in the last few years, as we used to have this X-axis motor behind the wall of the machine, and that would include extra parts coming up and driving the slide. Well, we got the chance to be able to direct mount these on the slide, so the direct drive, which is great for serviceability and access. And then there's many quick change tooling interfaces for these slides. So in recap of this slide, the slide technology is certainly the key, meaning that the only thing that determines whether you're cutting an ID feature or an OD feature at these slides is what you mount on the slide. Rear end machining, powerful single or dual synchron spindles. Of course, this is your pickoff spindle, and it's available in either 1 or 2, up to 14 tools for backworking. Again, proving the capabilities of our backworking, with 8 live available. And then the possibility of up to 2 tools simultaneously in cut. C-Axis is at your synchron spindle as well too, for at full RPM, as the slide says, and then for all your positional machining needs at backworking. The swivel time of just 0.4 seconds. Again, flexible is the name of the system. Here's some configurations. Let's take a look at this slide and talk about it a little bit. A 6 or 8 spindle machine is available from Index. And on top of that, a double 3 or double 4 machine to double output per cycle. So what that means is either 1 or 2 synchron spindles. That last statement there, additionally, dual synchron configures offer double backworking for complex parts. So when your backworking is actually your cycle time, we can split that up, decreasing that cycle time, or a double drop of less complex parts. If you are able to run a complete part in 3 or 4 spindles, we can do dual indexes and drop 2 parts at a time. Automation. Automation is available in the Index Multi-Spindle integrated 6-axis robot, which is actually our design and our integration, suitable for chuck parts, feeding and discharging of work pieces, and available are single, double, or quadruple rippers. So the automation is not an afterthought, it's something that we do. And then the second example is the stationary removal, which is our ejection from the synchron spindle out into the conveyance system out of the machine. And then there are some additional load and unload options available for different part length and diameter configurations. Industry 4.0, all the rage in our industry right now, and we're ready for it. Latest generation solution line control, touchscreen, X 4.0 ready for Industry 4.0 integration, again, as we are up on all the data collection needs. And then an optional VPC box allows virtual machine access. So what that essentially means is using our offline package right on the control itself, or some advanced programming and maybe programming conflict needs. So here's a quick rundown of the product that's available and the sizes that are available in the Index Multi-Spindle. So let's start off with the MS-16 and then the MS-16 Plus. The bar diameter capacity of this machine is a 22 millimeter bar, and it's a 6-spindle machine only. It does have a 10,000 RPM spindle, and it does have a power in kilowatts of 15, and the Newton meters for torque is 18. The next two products are the MS-22. One's a 6-spindle and one is an 8-spindle. You'll notice that the 8-spindle allows you to go up to 24 millimeters in the bar diameter. And they both are at a 10,000 RPM rating at the spindle. The kilowatts on both these machines is 15, and your torque is at 18 Newton meters. In the middle of the product range is the MS-32-6, 32 millimeter machine. Number of main spindles, it's only in a 6-spindle. Your RPM is at 8,000. Your kilowatt rating is at 19, and your torque is at 40 Newton meters. And then we have the two MS-40 products, the MS-40-6 and the fairly new MS-40-8, both 40 millimeter bar capacities. Number of main spindles, 6 and 8. These are rated at 7,000 RPMs, both of them. Have a power in kilowatts of 24, and a torque in Newton meters of 57. And last but not least, the MS-52-6, a 52 millimeter machine. Number of main spindles is 6. There's a 5,000 RPM at the spindle. The power is at 30 kilowatts, substantial power on this one. Torque is at 130 Newton meters. So you can see across the board that not only do we have a good size range, but we have a pretty good power rating for taking some healthy cuts in the process. The MS Series advantage: productivity, unmatched versatility, flexibility is the name of the game, accuracy, and totally connected to the 4.0 world. So if you would, please join me in taking a look at this video, which is a pretty cool video. It actually takes what looks like a complex machine and breaks it down by spindle to spindle, allowing you to engulf the concepts. So first of all, you see the openness of the work area. Again, big capability. You can see how how gravity can take effect and the chips can fall. And this is also a good shot at some of the tools that are capable of mounting on our slides. You'll see live motors, you'll see right angle holders. This also takes a look at some of the features that we discussed. 8 independent built-in spindles, 3-ring Hearth coupling. And this is a great picture of how we cool our spindles. Now we're going to start taking a look at our slides, and this should be showing us the X-axis cross slide, which is essentially a box wave, rigid enough. And then the Z-axis, hydrostatic bearing, excellent dampening. I believe we have like 50 bar of oil pressure that is being pumped in there while we're sliding back and forth. There's the Y-axis capability, a little example of how that works. And the swivel synchron, which in this case is a hearth coupling for its positioning. Very accurate, very repeatable. So this breaks it down, like I said, position by position, and we'll start taking a look at some of the processes that are available. Bar feeds out, facing off. We're going to do a couple tools and cut at the same time, which is the whole key to all this. Overlapping processes. Moves over to position 2. Again, going at it with a couple of tools. In this example, we're doing some grooving and polygon turning, which is a very prolific operation for us as we use that to create hexes on round bar quite often. Here's some Y-axis moving itself, and then there's a engraving going on. You see the C-axis action of the spindle as well. And supporting, and thread rolling in this case. Cross drilling. And contour milling. So now we're going over to position 8, and that means we're going to part off the part and perform the back working. I have a cool video, shows a invisible pickoff spindle so you can see everything. And this particular machine has 2 slides to back work, and you'll notice the action of live tooling going on. And then eject the part out into the conveyance. Machining possibilities are unlimited. And this is a great example of the flexibility of the slide system. Here we are exchanging 2 positions. So there really is no set address for one tool at one address. This is just showing the 8-spindle configuration of single synchron. I'm guessing that in this operation, the part needed all 8 spindles as it had complexity to complete. That would be the use for the single synchron 8-spindle. Lots of tools. And notice the color coding, if you would, on this particular example of a double 4. This is a double index where we are actually dropping 2 parts, either the same parts or 2 of different parts within 4 spindles. So you'll notice how it's double indexing if you look at the color coded parts. So here we are cutting the cycle time in half. And last but not least is the double back working. This is also cutting off 2 parts in most cases, but it's also double indexing. But this is the solution for when your back working is your cycle time, which should never be the way it is. You should always be able to keep the main spindles moving along, and doubling up on the back working with 2 synchron spindles allow you to do this. quick shot of the Siemens control, touchscreen control. Thanks for going through that with me. And we'll be switching to the rest of the webinar here in a couple seconds. Back one slide. So this is the slide of our national network at Index. Of course, Index has a very large headquarters in the United States, where it houses everything needed to support our customers. You'll notice that the gist of this slide is showing you that over 70% of our team members is customer support and application. So we are geared to take care of all customer aspects of support. And Index is here to help. It's obvious that the world has changed, that we have to adapt to this change. Business is not what it was months ago, with some dramatic drops in activity. And unfortunately, perhaps some of us have more time on our hands than we want. However, now is the time to use this period in business to your advantage. And look how you can be more efficient for the present and the rebound. And Index wants to help with that, with optimization of existing applications, time and cost studies, preventive maintenance, and operator training. We're here to help. Thanks so much. And at this point in time, we will be taking questions.
Okay, thank you, Tim, and thank you, Ross. We have a handful of questions here. I will just go through these in the order received. Everyone, if you have any additional questions, please just enter those in the box as we work through these. So first off, how much training is normally required to get a lathe operator proficient at running a multi-spindle?
Okay, Jim, I'll go ahead and answer this one. So actually not much. When a customer receives one of our machines, we offer 32 hours of training, and this is normally more than sufficient. Most lathe operators have experience with CNC technology, and going to a multi-spindle where you break everything down into spindle positions, you only have 2 slides per spindle position. It actually is pretty easy to get the hang of.
Okay. Next, we had, do the cross slides incorporate a dead stop similar to traditional multis?
No.
No, they don't. Yeah. Servo driven. Go ahead.
Yeah. Fully CNC, servo driven, so no, they don't.
Okay. Here, one of the slides referenced robot loading and unloading of parts. How common is that? It seems like a bar feeder would normally be used.
I'll take this, Ross, and that's a very good question. Bar feed is a dominating factor in this in our most of our projects. However, when the demands call for near net shaped parts, which they do quite often for material specs, this is typically the solution for that. And from my experience, real world experience, there's a number of machines here in the United States that are doing the robot load.
All right. What is the RPM of the live tooling?
6,000 RPM, but there are lots of different. Well, for VDI live tooling is 6,000 RPM, but you have different tool holders available which can increase, speeders which can increase your RPM by 3 times, so up to 18,000. You also have HSK tool holders which go up to 10,000 RPM.
Would a multi-spindle be suitable for small parts that require more milling and drilling than turning operations?
Yeah,
Ross,
absolutely.
Go ahead.
You want to go ahead, Tim? You can answer this one.
I was just going to say that yes, that's absolutely. We have a number of customers that do just that because all these capabilities that we described in the presentations are available at the multi-spindle. So typically, there's a lot of milling going on within the multi-spindles.
Okay. We have one. If you're not sure about incorporating an index unit into your production, how much would a time study cost?
Nothing. We would be happy to do the time study for you.
Okay. Then we had, so I don't know if we want to get into this. I'll defer to you, Tim. What's the starting price point for the MS series?
I would like to know if he could, I would love to have that question offline through the distributor or sales network. Be more than happy to discuss all that with him offline.
Okay. Can you please speak to changeover times and how they compare to traditional CNC lathes?
Well, changeover time can then be anywhere from a couple of minutes. So if you have to change programs, it's a couple of minutes. If you have to pop out a couple of tool holders, then also it's very quick. It's when you start changing out bar sizes where the setup time can go up because you start removing spindle liners, pusher collets, main spindle collets, chuck jaws. Then you're looking at a couple of hours. So, I mean, maybe 4 hours tops. So it's very quick compared to an old style multi-spindle machine. Maybe it takes a little bit longer than your CNC twin spindle lathe, but not very long at all. Once you get used to it, then obviously it moves along a lot faster.
How often are form or shave tools used?
It really depends on the application. Some customers want to still use them, and we're fully capable of doing that. So we see it not so often. Most people try to go with standard tooling, but for very quick cycle times, it still makes sense. So we do see it, but more often than not, people are using standard insertable standard tools. So.
Can I mention that in there as well too? As Ross says, yes, we still do employ form tools, and if it's advantageous to the cycle time, we will do that. However, for the flexibility of the system and the cost to produce the part, being able to use a single point tool and just adjusting geometries and the control is our first attempt. But small form tools are used if it makes sense.
Okay. What is the typical repeatability or CPK of various part features?
Well, it really depends. If you look at the material, length of cut, if you have a tool dedicated to that feature or not. I mean, we've held tolerances as low as 0.4. We've achieved SPC values of well over 5, but it really depends on the tolerance that you're looking at. So obviously when you get down to a few tenths tolerance, CPK is not going to be very high, but so generally the machines are very repeatable. We have customers running our machines who were employing post-process gauging, and they found after a while that the machines are so repeatable they didn't even have to rely on that anymore. So the machines are very repeatable, and they have to be just because of the sheer volume of parts you're producing. So you have to have confidence in your process. Hope that answers it.
What CAD programming package is usually recommended?
I'll answer this, Ross. We typically don't get into CAD/CAM system because of the number of features and the number of axes that we're talking about. In fact, it'd be very difficult to find a post for, if at all, for an index multi-spindle. There's a number of ways that people program these, and Index actually sells an offline system to help with that as well too. So there's really not a CAD/CAM system that works. However, I do know customers that will utilize CAD/CAM systems to create geometry and then take it out to the machine and copy and paste.
Okay. What is the typical response time of on-site emergency services and spare parts?
That's a good question, and we tout a 24 to 48 hour response time.
And then we had someone ask if they could get a copy of the presentation. I'll take that one. Yes, we will be posting this entire webinar online later this week, and we'll send out a link if anyone wants to go back and review it or share it with any colleagues who are unable to join us today. It looks like that was the last question. So if nobody has anything else, I don't see anyone typing. I just want to thank, I guess, first, Ross and Tim for presenting today. We appreciate you taking the time, and especially to all our attendees who took time out of their schedules to join us and hear what we had to say. We appreciate that. Thank you very much, and we will talk to you soon.